All right, here's the barrel room. I call it the gates of heaven. Some of the most common questions you're gonna get about bourbon is what makes it a bourbon and not a whiskey? In order to be a bourbon, it has to be made with at least 51% corn, made in America, aged in virgin oak barrels. A virgin oak barrel means that it's never been used for any other type of spirit. A lot of times you'll hear that it has to be made in Kentucky, which is not true. It has to be made in the US. They will also say it has to be made with American oak, which is also not true. It just has to be virgin oak. It can't be distilled over 160 proof, and it can't be barreled over 125 proof. Those are the 5 laws. The last 2 I told are not as common of knowledge. So if you just know American, virgin oak, and at least 51% corn. When you do get in here, you can show off the youngest and oldest barrel. To figure this out, you're gonna look at the date that it's filled. We'll age it for 2 years prior to that and then release it. Some of them still have the birth date on them, some of them do not. Also the barrel number. So what I like to do is take the bung off and let them smell the barrel. I like to do a brand new barrel and a soon to be released barrel. So the brand new barrel would be all the way over here. Let them smell that first, and then have them come over and smell the barrel that's right about to be released. The difference is that it's going to be a strong alcohol smell on the new barrel, where it'll be much more confectionery flavors on the barrel that's right about to be released. Also, we have a Irish whiskey style whiskey aging in barrel 3 here, and also in barrel 1. Barrel 1's a little bit harder to get to, but it will be released sooner. So this is barrel 1 here. It does say it on the outside. Depending on how busy my day is, or if they have a Groupon, I'll take the guests all the way back to the barrel room. If I'm really busy, I'll start right here with the reverse osmosis machine. I like everyone to know at least 2 to 3 things about each one of the machines so they can give an in-depth tour. So the reverse osmosis machine has 2 filters here. It takes the water and removes the aluminum sulfide, chlorine, and fluoride from it. The clean water comes out of the blue line. The water that has all the chemicals in it comes out of the red line. We only use this water in the final proofing process. Proofing is the industry way of saying watered down alcohol because it comes off the still too hot for people to drink it. Right here is a hot water tank. The hot water tank is used more as a recycling of water storage than to heat up water. We can heat up water extremely quickly in it. However, on our condensers, those tall silver columns over there, they end up using water that never touches anything. And so instead of just wasting it, we bring it back into the hot water tank so it can be used again. Right here is the mash tun. In the mash tun, we take starch and turn it into sugar. This happens by heat. The best example I can give is if you were to bite into a piece of corn, it would be very starchy and hard to eat. Whereas if you barbecue it for a little while, it becomes sweet. That's what happens in the mash tun. We auger over the grain into the mash tun, heat it up. When I'm making vodka or gin, I'm essentially making a giant pot of cream of wheat. When I'm making bourbon, I'm making basically a wheated polenta or a wheated grits, depending on where you grew up and what you ate. Next here is our fermentation tank, and we're actually fermenting right now, so you can see all the bubbles moving here. After we turn the starch into sugar, we bring it into this tank and add yeast to it. Yeast eats sugar and it makes CO2, which you saw down there. Its other byproduct is alcohol. We don't need the CO2 because we're not making beer. We don't need the distiller's beer to bubble in the still. However, we do need that alcohol so we can extract it out of the liquid. First, we'll bring all the spirits into the large still here. The rule of 3 comes into play in the large still. So let's say I had 1,000 liters at 10% alcohol in the fermentation tank. When I bring it into here and distill it, I'm going to end up tripling the alcohol content, but reducing the volume by a third. So that would take it from 1,000 liters down to 333 liters and increase it from 10% alcohol up to 30% alcohol. That's called low wine. It doesn't smell or taste good. We don't do any of our cuts yet, so there is still poisonous alcohol in it. After that, we'll run all of the alcohol, regardless if it's vodka, gin, bourbon, Irish whiskey, through the still again, and then determine what we need to do with it next. Both bourbon and Irish whiskey are done at this point. We'll take the contents, proof it, and then barrel it. If we're making vodka or gin, it's going to go into the small still. The small still is connected to these tall columns here. In each one of these windows, the alcohol concentrates and gets stronger as it moves its way up the column until it gets to the top window there. And right above it is a partial condenser. That turns almost all the vapor back into a liquid, which falls back down and then comes into this pipe here and back into the still. Only the very strongest stuff makes it into this window, where it goes through that same process again. Most of the vapor turns back into a liquid, falls down, back through that line and back into the still, and only the absolute strongest comes out of our parent window here at 95% alcohol. This is a condenser, and this is a condenser. That's where I spoke of earlier that the water ends up being used but never touches anything but metal, and so we send it back to our hot water tank there to recycle the water. Couple cool tidbits. We call this our whiskey cow because it looks like it has udders on it. In our H3 room, you'll notice that there's a bunch of old Smith Brothers milk containers. Those are all our different fractions for our gin. We distill each one of the flavors that we mix together in our gin independently, and then we blend them back together on this giant scale here. Here's a vodka filter. It's huge, full of carbon. The point of the vodka filter is to eliminate any other flavor that's left behind before it goes into the bottle, where this here is a gin filter. The gin filter is just to prevent anything from going into the bottle that might have fallen into the liquid. In the laboratory here, we can do 2 ways of testing the alcohol. We can do your old science class with a graduated cylinder, drop a hydrometer in there, which looks like a giant thermometer for an elephant, find the meniscus of the liquid, that layer that the water sits on. And then we have to do a room temperature, a liquid temperature, and then an interpolation. Or alternatively, we can take a little syringe of the alcohol, put it into the side here, run this machine, and it does all the work for us. And it also has a USB port on the side, so the TTB, the former ATF, can come and check that we're being compliant. We have a few other tools, our labeling machine in here, but nothing that anyone needs to get too in depth with.